polythene piece rubbed with wool is found to have a charge of minus 3.2 into 10 to the power of minus 7 coulomb. Then the options are given as follows. C. We are given the data, right? According to the given data, we know that Q is equal to NE, right? Q is given and E is given, N we should find out. So Q by E is equal to N. We know the value of Q, which is also given, right? Q is given as minus 3.2 into 10 to the power of minus 7 coulomb by E. E is always the constant minus 1.6 into 10 to the power of minus 19 coulomb is equal to N. So minus is, now find out the number of electrons. Minus minus gets cancelled and 1.6 2s are 3.2. So 2 into 10 to the power of minus 7 and this goes up becomes 10 to the power of 19. 2 into 10 to the power of 12 because 19 minus 7 is 12. So we got N as 2 into 10 to the power of 12, right? So the electrons are transferred. How do you know that the electrons are transferred? So to explain this, the loosely bound electrons will be transferred from wool to polythene. If you ask me how, the loosely bound electrons will be transferred from wool to polythene, and so it acquires a negative charge. So the answer is wool to polythene. Fine. Now there are two charges, one microcoulomb and plus 5 microcoulomb, which is separated by a small distance. The ratio of forces acting on them will be, see, we have two charges plus 1 microcoulomb and plus 5 microcoulomb, which is separated by a distance. Consider one charge to be at A and the other to be at B. D is the separation between the two charges. We need to find, WNTF means we need to find the ratio of forces acting on the two charges, right? On each charge. So we are given that only two charges are present in space. No other charge and nothing is present in space other than these two charges. So one will be influenced by the other only. So F1, force on Q1 due to Q2. Let's take Q1 as plus 1 microcoulomb and Q2 as plus 5 microcoulomb. Okay. So force on Q1 due to Q2 only, of course, 1 by 4 pi epsilon naught Q1, that is 1 into 10 to the power of minus 6 is micro, right? 1 into 10 to the power of minus 6 into 5 into 10 to the power of minus 6 by d square. The separation between them, right? F2, force on Q2, is of course due to Q1 only, because only charge is Q1 there. 1 by 4 pi epsilon naught into 5 microcoulomb, that is 5 into 10 to the power of minus 6 into 1 into 10 to the power of minus 6 divided by the separation between them, it is d square. The square of the distance between them. Fine. So F1 is equal to F2, F1 by F2 is equal to 1 is to 1 or 1 by 1, anything like that. Fine. So which option is this? Let me see. Option B. Now I'm not going to read the question, you can read it because it's a pretty long question. So we are given three charges, 4q, big Q and small q, at the on the same line are the positions 0, L by 2 and L. Okay, so let's write it down. Sorry, small q, 4 small q, big Q and small q again. Okay, we are given three charges. 4q lies at 0 and q lies at L by 2 and small q lies at a distance L from 4q. We need to find the resultant, I'm sorry, when the resultant force, when the resultant force on small q is 0, and also we need to find the value of the charge big Q. Okay, the value means how, yes, it's, we can say it's the value, what will be the value of Q for the resultant to be 0. Forced force on Q should be 0. So for the resultant force on small q to be 0, what will be the value of the charge big Q is the thing we need to find. And to do that, I'm going to show you the steps. Force of Q, force on the charge Q, please correct it. Force on the charge Q due to 4Q is F1. Let me take as F1 is equal to 1 by 4 pi epsilon naught into Q into 4Q, or 4Q into Q divided by the separation between them, the square of the distance between them, which is L square. So force on the charge Q due to big Q is F2. Let me take as F2. F2 is equal to 1 by 4 pi epsilon naught Q into big Q, sorry, big Q into Q, anything, divided by the square of the distance between them, which is L by 2 the whole square. Now the resultant force should be 0. It should be in equilibrium. So F1 plus F2 is equal to 0. So let me erase the top writings so that you can see it clearly. Hope you have copied that. 1 by 4 pi epsilon naught into 4q into q divided by L square, 4q into q divided by L square, plus 1 by 4 pi epsilon naught q into q divided by L by 2 the whole square equal to 0. Right? So 1 by 4 pi epsilon naught and 1 by 4 pi epsilon get cancelled when the other thing goes to the right hand side. So q and q again will get cancelled. We are left with 4q by L square is equal to minus q divided by L square by 2. L square by 4 will be the 4 will go up, then again 4 and 4 gets cancelled, and again L square and L square will get cancelled. Okay, L square L square cancel, 4 gets cancelled. Okay, q is equal to minus big Q, or my q is equal to minus small q. Right, I shall erase this and write it clearly so that you can see. The final answer is the value of big Q for the resultant force on small q to be 0 is minus q, which is, and what is the option there? Option A or B? Option A, right? the separation between two protons so that the electrostatic repulsive force acting on either of them is equal to its weight is. The options are given as follows. So, we are given this separation between two protons. We should find the separation between two protons. So, we are given that the force between two protons is equal to the weight of each proton, or the weight of a proton, and we know that weight of a proton is 1.67 into 10 to the power of minus 27 kgs, which you need to remember. It's a very important value, weight of a proton and the charge of a proton, charge on an electron also. 1.67 into 10 to the power of minus 27 kgs. So we can also take it as 1.67 into 10 to the power of minus 27 is equal to 1 by 4 pi epsilon naught. 1.6 into 10 to the power of minus 19 is the charge of a proton, right? The proton charge is that into 1.6 into 10 to the power of minus 19 divided by d square, or r square, which is the separation between them, square of the distance between them. So we have r square is equal to 9 into 10 to the power of 9, the value of 1 by 4 pi epsilon naught, into 1.6 into 10 to the power of minus 19 into 1.6 into 10 to the power of minus 19 divided by 1.6 into 10 to the power of minus 27, right? So 1.6 get cancelled, and 1.6 into 9 remains. 1.6 into 9 is 144, that is 14.4. 38 minus 27 is 11. So 19 plus 19 is equal to it becomes as, wait one minute, r square is equal to 9 into 10 to the power of 9. So 10 to the power of minus 27 comes up and becomes 10 to the power of plus 27, right? 1.6 into 10 to the power of minus 11, right? So 1.6 into 9 is equal to, it is 14.4. 14.4 into 10 to the power of minus 2, if I am not wrong. So if we take the square root of this, we get the value almost to be 0.119, if I'm not wrong. 0.1 yes, the value is 0.119. R square is equal to 14.4 into 10 to the power of minus 2. R is approximately equal to root of 14.4 10 to the power of minus 2, which is approximately, let me calculate once again, 0.9, no, this is 0.1, this is 0.119, yes, meter, option A. Thank you. Two free charges minus 4q and minus q are at a small distance d apart. The charge which keeps the system in equilibrium is. The options are as follows. So we are given that two charges. Always write the given data first. Two charges, write 2 points A and B. minus 4q and minus q are separated by a distance d, right? So given data, what will be the distance of charge q? Let's take another charge q which is at a certain distance but not at the center, right? It may be at the center also, but we are not sure. So we should find the distance of the charge q from minus 4q or minus q, and the value of q also we should find out, right? So see, if the charge q is at a small distance x from minus 4q, and it means that the charge q is at a small distance d minus x from charge minus q, because this whole distance is d. So if we subtract x from d, we get the charge q distance from minus q. Okay, we get, so we are given that F1, force on charge q from minus 4q is equal to force on charge q from minus q, right? The system is in equilibrium, right? So it is 1 by 4 pi epsilon naught q into minus 4q divided by x square is equal to 1 by 4 pi epsilon naught q to minus q by d minus x the whole square. So 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught get cancelled, q get cancelled, small q and small q also get cancelled, minus minus get cancelled. So we are left with, I shall erase the top writings. Four by x square is equal to 1 by d minus x the whole square. So by cross multiplying we get 4d into d minus x the whole square is equal to x square. By taking square root we get 2 into d minus x is equal to x. 2d minus 2x is equal to x, or 2d is equal to 3x. So we get d is equal to, x is equal to 2 by 3d, right? So let's keep this as it is. X is equal to 2 by 3d. Note it down at a corner, in the corner. So now we got the value of x in terms of d, right? So now it's a bit easy for us to find. We got x is equal to 2 by 3d, right? So f1 plus f2 is equal to 0, equilibrium 1 by 4 pi epsilon naught 4q, minus 4q into q divided by x square plus 1 by 4 pi epsilon naught minus q into q divided by d square is equal to 0. I'm sorry, It should be minus 4q into minus q. I shall just erase it and change it again. It should be minus 4q into minus q, if 2, right? If I'm not wrong, yes, it should be minus q, because the distance is d square from minus 4q to minus q, right? So minus 4q. Here too it should be minus 4q. Sorry, small q. Minus minus gets cancelled now. 4 gets cancelled, q gets cancelled, and we are left with q by x square is equal to q by d square. So we got the value of x to be 2 by 3d. So 2 by 3d the whole square is equal to q by d square. Q 9q by 4d square is equal to q by d square. D square gets cancelled. So the value of q in terms of small q is 4 by 9q. This is given in option, let me see which option is this. Option yes, option A. Thank you.